This is the reciprocal of x parent function. Also sometimes called the rational parent function. The equation for this one is f of x is equal to 1 over x. This very literally says the reciprocal of x. Now I could pick some x values to put in here, so I'm going to pick a -1, 0, 1, and 2. If I put -1 in place of the x here, then this would say the y is equal to 1 divided by -1. 1 divided by -1 means -1. So the y value would be -1. If I put in 0, then this would say the y is equal to 1 divided by 0. Now if you remember, dividing by 0 is not something that's mathematically possible. It is considered undefined. So for this one, I don't get a numerical answer. I'd say that it's undefined. If I put in 1 in place of x, then that means it would say the y is equal to 1 divided by 1. 1 divided by 1 is just 1. And if I put in 2 in place of the x, then this would say y is equal to 1 divided by 2, which is 1/2. I'm going to go ahead and plot the points that I have. I'm probably going to need more in order to see what this picture looks like, but we'll develop those. So I'm going to start with -1, -1. So I start at the origin, I go to the left one and down one. Now 0 is undefined, so that means when x is 0, I'm not going to be able to put any points anywhere. So I'm going to skip over where x is 0. Next point is 1, 1. So I'd start at the origin and I go to the right one and up one. And the next point is 2, 1/2. So I'm going to start at the origin, go to the right 2, and up 1/2. So that means I'm only going to go up halfway between the x-axis here and the first horizontal line. Now there's really not enough there for me to see what's happening. So I'm going to pick some more x values. I'm going to start maybe with another one on this side over here, so a -2. If I put in a -2 in place of the x here, it would say y is equal to 1 divided by -2. 1 divided by -2 would be a -1/2. So go ahead and plot that point. So -2, -1/2. I'd start at the origin, go to the left 2, and down 1/2. It did not get any clearer for me yet, so I'm going to continue picking x values until I can see what this one looks like. So maybe we'll pick 3. So I'm going to build onto this side of my table now. If I pick 3, then this would say y is equal to 1 divided by 3. 1 divided by 3 is just 1/3. So we'll go ahead and plot that point. So let's see, I'd start at the origin, go to the right 3, and then up 1/3. So that means just 1/3 of the way to the first line there. I'm starting to see a pattern over here. It looks like as I move out this direction, the points are going to get closer and closer and closer to the x-axis. Like if I picked 4, I would get 1/4, so that would be about here. And if I picked 5, it would be 1/5, so a little bit closer still. And if I picked 6, it would be 1/6, so closer even still. And no matter how far I go this direction on the x-axis, how large an x I choose, I'm going to be still getting a y value that's 1 divided by whatever that x value is. So it's still something a little bit larger than 0. So I'm going to go ahead and connect the dots that I have so far. And then also imply the pattern that we just discovered, that it's going to keep getting closer to the x-axis. The y's will keep getting closer to 0. Now I know when x is 0 that this function is undefined. So I really need to know what's happening here between 0 and 1 so that I can figure out how to draw the rest of this side of the graph here. So I'm going to need to pick a number for x that's between 0 and 1. So maybe I'd pick a 1/2. So my x value is 1/2. So if I put in a 1/2 in place of the x here, then this would say 1 divided by 1/2. Now dividing by a fraction, if you remember from middle school, they taught you that it's 1 times the reciprocal of the second fraction there. So the reciprocal of 1/2 is just 2 over 1. So 1 divided by 1/2 is really just 1 times 2 over 1, which is just 2. So when x is 1/2, the y is 2. So I'm going to go ahead and plot that point, 1/2, 2. And similarly, if I pick something that was a little bit closer to 0, like maybe a third, and then I follow this same idea here, this idea over here, 1 divided by 1/3, then that would say 1 times 3 over 1, which is just 3. So a little bit closer to the y-axis would give me 3. And if I got even closer to 0 with my x, like say 1/4, then I would get 4. And if I picked 1/5, I'd get 5. And so it looks like the closer my x's get to 0, the larger the y's are getting. And no matter how close I get to 0 on the x-axis, the y's are still just going to keep getting larger and larger and larger. So it kind of implies that this graph is getting closer to the y-axis. Now I did notice with those first 2 points on the left side here, that they kind of mirrored the first 2 points that I did on the right side. So that means it's probably going to handle the rest of the points over here just like it did on the side that we graphed already. Just to be sure though, let's go ahead and pick an x value over here, like -3. If I put that in for x, it would say the y is 1 divided by -3, which is -1/3. So that'd be -3, -1/3, about right there. Looks like the pattern's continuing. So I'm going to go ahead and connect these points. As my x's get closer and closer to -infinity, the y's are going to get closer to 0, but this time from the bottom side. And as I go this direction, as I pick x's that are between -1 and a 0, it's going to kind of mimic what's happening over here, only going the opposite direction because they'd be getting more and more negative as we get closer to 0. Okay, this function has a couple of features that are really important to know about. They are called asymptotes. Asymptotes are essentially boundary lines that tell you what's happening as the graph gets closer and closer and closer to them. Now this one has 2 asymptotes actually. It's got one that's vertical, and that's right here. I'm going to draw it in using a dashed line here. This vertical asymptote is it's your boundary line telling you what's happening as the x's are getting closer and closer to 0. The equation of that asymptote is x equals 0. The other asymptote is horizontal. You can see as we go out this direction forever, the graph is getting closer to a y value of 0 from the top. And as we go out this direction, the y values are getting closer to 0, but from the bottom. So there's actually horizontal asymptote here. Draw that one in again using a dashed line. The equation of that one is y equals 0. Okay, so now domain. The domain is the set of all x values that I can put into this function, and it returns an actual value for y. So I could choose x's as large as I want, and I can choose x's as small as I want, negative numbers. The only x that does not work is a 0. So down here I'd say that x can be anything. So x is any real number except 1. So I would then say x does not equal 0. So x is any real number except for 0. That's what this notation means. Now similarly for the y's, the y values that we get are the reciprocal of whatever the x value is. So we can take the reciprocal of any real number we want to except for 0. So the reciprocal of 0 would mean you'd have to divide by 0. So I'd say that the y's also can be any real number except 0. Now I want to look at intervals for increasing, decreasing, and constant. I have to move from left to right on the graph in order to determine that. If my pen has to move upward to draw the graph, then I would say it's increasing. If it has to move downward, then it is decreasing. So here, very slightly, my pen is moving downward as I move from one place to the next, from left to right. And then it goes downward very, very quickly as the x's get closer to 0. So it was decreasing for all of this from a negative infinity all the way up to an x value of 0. So I'd say it's decreasing from negative infinity to 0. I use parentheses on both sides there because it tells me that it's this interval of x's from negative infinity to 0. Now in order to get back to the graph again, I have to lift my pen because there's an asymptote there. There's a value of x that's not included in the domain, so I have to skip over it. And that brings me to this part of the graph here, which is very high on the graph. As I move my pen from left to right, my pen is still moving downward all the way as far as I could possibly go, and if I could continue going on forever, my pen would still be moving downward, even though it's just doing so very slightly. So that means it would be decreasing from an x value to the right of 0, all the way out into an x value of infinity. So I'd say it's decreasing from 0 to infinity. And again, parentheses to indicate that it's from here to there. Now, when your answer for increasing, decreasing, constant, or anything that you're writing in interval notation has to take two different pieces, the way that you link those two together is you use a symbol called the union symbol. It looks like a U. There's no tail on it, though. Now, this actually says that it's decreasing for the entire domain of this function, for any real number except for 0. That's precisely what this says. So if it's decreasing for the entire domain, then that means it's never increasing. And it's also never constant. What you need to know about this function is the name of the function, reciprocal of x, the equation, f of x is equal to 1 over x, the shape of the graph, along with the two asymptotes, the domain, and the range. And of course, if you know the graph, then you can use it to determine intervals of increasing, decreasing, and constant.